Hi, everybody. Can you hear me okay? Excellent. Anyone want to write an automated test for this microphone? Make sure you can hear me. All right, that's the only bad joke I'm going to tell, so don't worry about it. Okay, so let's dig in. I think it's worth starting with the beginning. When I first started doing automated testing with Selenium about 6 years ago, I thought that it was this scary thing that I had to figure out. I wanted to go from one side of a chasm to another, and there was no bridge between the two. That's how it felt when I looked at the Selenium documentation. There was no clear path. And it's worth mentioning that after 6 years, the Selenium project's documentation hasn't gotten any better. So if you're just getting started now, you probably think the same thing. So what I think is worth pointing out, and the point in all this and what I learned is that it's not this big scary chasm you have to jump across. Working with automated testing within your organization is actually a lot more like a puzzle, like a Rubik's Cube. And how many people, show of hands, have played with a Rubik's Cube or at least know what it is? And but keep your hands up if you know how to solve a Rubik's Cube. I got a couple. Okay, cool. So you can ask them if this is true or not, but the cool thing about a Rubik's Cube is no matter its orientation, you can apply the same patterns to it and solve it. And I argue that the same thing can be done within any organization when it comes to automated testing. You may think that your problems are unique, but they're not. It's just a puzzle. You apply some patterns and practices, and voila, you're on your way to being successful with Selenium. So I always like to start with that story and this set of sentences. This is the goal, the reason we do all of this. We want to write business valuable tests that are reusable, maintainable, scalable, resilient across all of the browsers, and then you want to package them up so that you're not the one running them, that they're part of this ecosystem that you and your team use. And the best way to do that, I guess, is to understand a little bit about Selenium, make sure we're all on the same page and have a good working glossary of everything I'm going to talk about. And then we'll kind of dig in more into the weeds as we progress. So the first 45 minutes of this talk is really about kind of the end-to-end soup to nuts of what I think is an overarching approach to using Selenium successfully. And then in the second half, I'll cover some tips and tricks and more advanced topics. And then if you stick around to the very end, you get to see a mobile testing robot. So just spoiler alert. So Selenium is what it is, the Reader's Digest version. Selenium is a robot made of software sent from the future to help us test websites. At least that's what the creator, Jason Huggins, would tell you if you asked him over beers or coffee. And that's basically it. It's something that drives a browser in an automated way, and it mimics human action. It is good at mimicking human action, but it is not good at being clever. There are things that you can do with it if you really, really wanted to, like check the HTTP status codes of a page and resources on a page, but it requires additional setup, and it can lead to additional issues. So any time that you think, hey, am I being clever when I write tests? If the answer is yes or maybe, then maybe you need to stop and question whether or not you're using Selenium for what it's good at. And is this the right tool for the job? So as long as you're mimicking human action, you should be in good shape. There's various flavors of Selenium. I'm assuming and I'm hoping that you're all nodding your heads and you're like, yep, we already know this. So, but for the most part, just for the uninitiated, there's a record and playback tool, Selenium IDE. I'm assuming if you've ever heard of Selenium, you've heard of this, maybe you've used it. Don't use it. That's the easiest answer I can give you. There are, of course, exceptions to everything that I say here, but the way I approach a lot of this stuff is I give you recommendations, and when you have a clear understanding of why you want to do something different than what my recommendation is, great. Then you are ready to do that thing. But until then, if you have no clear understanding, just stick to these guidelines and you'll be fine. So record and playback, bad idea. Then when you have tests written in code, you can run them locally on your machine, or you can run them remotely on other machines. And then that gets into this whole conversation of a scalable grid, and is it your grid or somebody else's grid, and so on and so forth. Selenium mostly has a bad rap for being slow, brittle, and hard to maintain, but I'm going to cover a lot of practices and patterns and tips about how to actually structure things so that you can address almost all of those issues. And granted, there's always little nitpicky things that you have to deal with, and there's no such thing as 100% test automation or 100% perfection when it comes to automation, but you can get most of the way there. So, and before you really write tests, there's a couple things I want to talk about. Mainly defining a test strategy, and this isn't like this really abstract concept. I actually distill it down into 4 questions. And if you haven't asked these questions in your organization, or if you don't know the answers to these questions in your organization, then maybe you should ask these questions. So the first one is, how does your business make money? And if you don't deal directly in dollars and cents, if you're more of like a nonprofit, then how do you generate value for your user? And then what features of your application are being used? And since you're most likely not dealing with super secret corporate federal data, you probably have access to usage data, like Google Analytics, to be able to understand what actually is being used in your application. And then you can also determine from that usage data what browsers people are using. And then, this is a little harder, but what things have broken before in your application? Now, the easiest thing is when there's a release about to happen and you look and you see a developer sweating, you can go ask him, why are you so nervous about this release? And they're likely very nervous because there's something in the app that's broken before. There's something that's keeping them up at night. There could be also information in a defect tracker. There's a litany of places that you can pull this information from. And really what the answers to these questions give you is what to test and which browsers you should care about. Now, that takes you from figuring out everything you should automate to maybe the important things. And if you're already doing automation and you ask these questions and you have found things that aren't being covered by automation, then maybe you should add those to your automation cycle. How many people here already use Selenium in their organization? It's like 80, 90%. Cool. So I'm assuming you're all using Java. How many people use Java? Almost all. OK. Any Ruby people out there? Yeah, that's right. Yeah, cool. All right, cool. OK. So I have some code examples that are in Java in these slides. So for the non-Java people, I apologize. But hopefully it gets most of you going. I bring up picking a programming language partly for people that are new to this, but also for people that maybe already have a framework and then they're like, you know what, we're doing Java, but JavaScript's pretty cool. Maybe we should rewrite our framework. So the general, this happens more than once. So a lot of people think that you just write your tests in the same language as the application. That's just the default assumption people have when they go into automated testing. And instead, a better question to ask, who's going to own it? Now, if you're the front-end developer and you want to do testing and you write your front-end in JavaScript and you say, hey, I like JavaScript, let me write my test in JavaScript, I don't like Java, there may be something to that. But especially if you're going to own it, it gets you excited and you're going to want to write tests. Writing tests is a good thing. There's also the conversation of, do you build a framework or use an existing one? And I say an existing one because I keep a list of all of the open source Selenium frameworks that I come across in my journeys, and there's at least one for every language. The fun fact, I'm assuming you already know this, you're going to want to build your own. Nobody ever says, I'm going to use an open source framework. I know because I wrote one, and nobody uses it. So it's on that list if anyone wants to do it in Ruby.
I never know there is like a list of them.
Now there is. and if there's anything that's missing, if any of you look at this and say, hey, my framework's not up there, and it's open source, shoot me an email. My contact info will be at the end. OK, so let's talk real quickly about Selenium fundamentals. As I mentioned, it mimics human action. And there's a few common actions that you're going to end up using over and over again. And then Selenium, in order to work, it uses locators. And I'll cover what those are. But basically, the gist is locators tell Selenium which element in a page to interact with, which bits of HTML. So the common actions you're going to run into, just to get started, you're going to want to get a page. There's other ways within Selenium to do this, but get's the easiest, most common. You get a URL, and then you're going to find an element on a page. And once you find an element, you can do some actions to it. You can click on it, and if it's a form, you can also submit the form. And then when you want to type into an input field, you send keys. And then you can also see if something is displayed. And it's worth pointing out, that for all you front-end peeps out there, click and seeing if something is displayed, like there's a lot going on under the hood with Selenium. It's not just like a jQuery click event. It's like making sure the element is actually clickable. And when something is displayed, it's actually determining if there is an overlay on the page, is it actually not hidden? It's doing a whole bunch of stuff for you. So when it says, yep, it's displayed, it's just the rough equivalent, pretty close to a human actually looking at it and saying, yeah, I can actually see it. And it's actually enabled. I could click it if I wanted to, all that stuff. So in terms of different ways that you tell Selenium what you want to interact with, when you find an element, you specify a locator, and there's all these different strategies. And when it comes to locators, there's some really simple advice I like to give, and it's good locators are unique, descriptive, and unlikely to change. So when you put that in mind, that rules a few of these out. Now, if you take out link text and partial link text and tag name, you can use these, but just keep in mind that these could potentially be something that's more likely to change. Instead, try and start with IDs and classes. These are going to be the fastest way for Selenium to actually interact with an element on the page. And ideally, they'll be helpfully named. They'd have some sort of semantic markup to them. And then if you need to get to those harder to reach places, if you need to actually traverse through the page, then use CSS selectors or XPath. But do so with care, because you can write really poorly performing CSS selectors and XPath locators that are also extremely brittle. And in the past, and even still today, there is actually a lot of contention in the Selenium community about CSS or XPath. It's like this kind of internal battle. And it used to be that XPath was extremely slow in Selenium. And that's changed. The benchmark data people were referencing is several years old. So, and even mine is old, but a year ago I went through and I did benchmark tests for everything. And it's actually negligible. Like CSS is a little bit faster. So if you want to see the benchmarks and all the data, then check out that first link. And if you want to see some CSS and XPath equivalents, then you can check out that link. And the recommendation on CSS versus XPath, I typically go with CSS selectors, and I'm assuming all of you do, those of you that actually write Selenium tests now. And then for those harder to reach things where you want to go and traverse backwards up the page, use XPath. Now, in terms of finding quality locators, hopefully most of this is rudimentary for you guys, but there's the obvious right-click on an element in your browser and inspect the page. If you're using a modern browser, hopefully you all are, not Lynx or IE6 or something like that, then you can inspect the page and see what the markup is. And verifying your selection. Now, like in a Java console with jQuery, all you front-end guys will know this is really easy to do. But for those that don't know, if you're just starting with automated testing, what most people do that aren't developers who do automated testing, they look at the page, they find the locator they want, and then they go and they write their test, and then they run their test, wait for the browser to load, and look and see if it did what they thought it was supposed to do. And then when it doesn't, they go, oh, shucks. And then they go back to the page in the browser, and then they reinspect, and they look again, and they go, I got another locator to try. Then they go back to their test, and it's extremely slow feedback. Instead, you can verify your selection in the browser. And there's plugins galore for this, but if you end up using Firefox with Firebug, there's Firepath and Firefinder plugins that give you the ability to drop a locator into an input field, hit enter, and it actually highlights it. It outlines it on the screen for you. It saves you a ton of time. And so hopefully, maybe there's a couple of you that have like, oh, wow, that will save me time, because it'll save you like hours a year and a lot of frustration. So I have a write-up on how to use Firefinder. Steps through like an actual issue I had when trying to do the benchmarks with CSS and XPath. So real good use case there. And then there's this locator game. If you're new to locators, specifically CSS selectors, this game is really interesting. It's an open source game. It's just these little dancing plates, and then you have to type locators, and then it like, so you can actually hit targets on the plate. It's really interesting. So potentially a fun way to dig in on that. And then having a conversation. A lot of times when you're if you're not the front-end developer and you're just a tester on the team writing tests, it's very much a arm's length kind of experience where you're trying to write tests for this thing you didn't build, so you're trying to understand the markup, find elements that you want to click on, and then figure out a way to write your tests to do that. And there's plenty of times where the markup on the page is not built for automation. It ends up being a very challenging exercise. And then what you end up with, you may end up with working test code, but it may be brittle. And if you just actually had a conversation with the devs and said, hey, here's what I'm trying to do, they may go, oh, try this. Or, oh, let me add a unique locator to the page. And then poof, your test writing is easy. So, and then they get a better understanding of what you're trying to do all the time, and they may actually change how they build and construct the apps you're testing. So communication, collaboration, all that good stuff. Here's a quick video of Firefinder in case you're interested. Once you open Firebug, there's a Firefinder tab that gets added. You can inspect, and hey, look, there's this ID login. Let me see what that looks like. You type it out, hit enter, ta-da, you get dashed outline of the element on the page. And we could do the same thing for the username field and the password field to make sure we got that. And then we realize, well, we do the button. That's cool. All right. So we could take those locators and write our first test. But before we do, it's worth talking about good test anatomy, just to make sure we're all on the same page, because a good test has like a handful, a few things that really should exist in all tests. Your test should be written to use some kind of framework that already exists, a test framework, whether it's a behavior-driven development framework or an XUnit framework of some sort, because it gives you the structure you already need and gives you the ability to run your tests. It gives you all the minimum reporting that you need in terms of like how many tests ran, how many failed, et cetera, et cetera. It just gives you a lot of functionality that you don't have to build. And each test, ideally, will test one thing. It will be atomic. It will have a single assertion. And each test should be able to be run independently. There should be no dependencies between tests. One test shouldn't run to set up another test. And this is a big one because if you don't do this, you won't be able to run your tests in parallel. And then you want to make sure that anyone can understand what the test is doing, not just another teammate, but potentially you 6 months from now when you come back to the code and you look at it again. And this falls back into the are we being clever category. Ideally, testing is really just a boring activity, so you should write boring test code that is easy to understand, that doesn't do anything clever. And then you want to make sure that you group similar tests together. So if you actually want to create some sort of custom test suite that does like, I want to check login, and then I want to check this purchase activity and this other stuff over here, you don't write a test file that has all those things. Each of those things live in their own files in the proper folders that denote that functionality. And then you can use metadata to actually tag each, label each of those things. And in Java with JUnit, it's categories, and in Ruby with RSpec, it's tags. But basically, at runtime, you can specify that label, and it will dynamically create a test pack for you that consumes all of those tests that you want to run. So that way, you don't have to. Each thing has its own place, and then at runtime, you tell it what you want to run, as opposed to trying to create it statically. So taking those locators, here's what Selenium would do to use them. It would first visit the login form with a get action, and then it would find the login form's username field, and then input text or send keys. It would do the same thing for the password, and then it would submit. You can click the submit button after you find it, or you could find the form and submit the form. So I have this website called The Internet. So I write and maintain the Internet, only because I could tell that joke. But this is the example where we're going to write the test against, which we saw when I verified the locators. So here's what the Selenium commands would look like in Java. Of course, I've removed the setup and teardown, but you have a driver object, which is the instance of Selenium, and you would get a URL, and then we'd find an input, submit. And what that looks like in a simple JUnit test is this. Granted, this is the very first test, so we have nothing abstracted. We just have our setup, which runs before the test, and we have the teardown, which runs after, and then we have our test method. And we're just loading an instance of Firefox. Now, when we run this, it will, of course, pass because there's no assertion. That's the other big advantage we get by having a test framework, assertions. So we can assert, we can determine if the behavior of the page is what we expect. And we can get that information with Selenium. So to find assertions, we would, for this example, log in, inspect the page after logging in, find the locator for it, verify we have what we expect, and then add it to the test. So for this, we'll just log in with the good old Tom Smith and his super secret password. And then afterwards, inspect the page. We'll start with the logout button. Maybe there's something helpful there that's semantic, but really it's just a button. There's no good locators. It's garbage. So then we inspect this flash message, and we see that in the class, there's actually something that says success, something semantic that denotes the state of the page. And so let's say, all right, let's grab the flash success message, and then a CSS selector for it would be .flash.success, because classes start with a dot, and then we get it, ta-da. So if we put this in an assertion, we would assert true, have a failure message that would appear if the assertion failed, and then we find using the CSS selector, and then we use it. After we find it, we say, is it displayed? And Selenium will look and say, yep, it's displayed. It will return a Boolean, and then we'll assert if that Boolean is true. And that's pretty much it. If we run this, it would work. And if there was something wrong with it on the page, we would know. And one helpful tip when writing assertions, or even writing anything with Selenium for that matter, it's worth trying to force your test to fail to make sure that it's doing what you think it's doing. And for this example, like fudging the locator, like over here, we'll do that. There's plenty of times I've written a test and I think I know it's going to do exactly what I think, and then I fudge the locator, and then it still passes, it doesn't fail. And then I'm like, what is happening? I don't know what's happening anymore. So I leave this comment really as a reminder to myself to give that mention to you, because it saved me a lot of headache by doing that. Fun fact, if you were to assert false, so if we wanted to go the opposite direction here and say, maybe the flash error message that would appear if we gave a bogus login info would appear, so we could assert that it didn't appear on the page. So we would check for the negative condition of something. So say, hey, Selenium, did something not appear on the page? And when we look for something that's not on the page, Selenium won't, is display will return true if it's there, but if it's not there, it won't return false. It will return an exception. So that's your runner-up prize. So what you get is a no such element exception. And this is just one of those things that we have to account for in our test code. And there's two common exceptions you're going to run into, no such element and style element reference error. For the most part, you can very easily just catch these exceptions and move on and not really worry about it. And if you want to see a full list of the exceptions, perhaps some light bedtime reading, feel free to check out that link. And in order to just catch on this is displayed and return false instead of an exception, we can just do this. We can try the action and return false if it gets thrown. So now that we have our first test, let's go ahead and make it reusable and maintainable. Page objects. Who here uses page objects? Who here knows what page objects are? That's funny. Fewer people than use them. Cool. All right. Guys are weird. All right. Page objects. Okay, so if we keep going on the way we're going right now, we will have all these tests written directly against our application. And then they'll fail if the application changes, and we have to go and update all of our tests, and then we'll have a sad face. Instead, what we can do is separate the concern. We can create a page object, a class, that represents features in our application, and put our locators there, and write our tests against that. And that way, we only have to update just the page object to make all of our tests pass again. And then we smile. And we're happy again. So do that. It's probably one of the most fundamental things that every test automator does. It's the most common pattern that's used because it's the most useful one. So let's look at a page object for our login example. At the top of it, we have some field variables where we specify the static locators, and then we use them throughout the rest of the class. Down here, we have the core behavior of the page, logging in with a username and a password. And then we just grab the Selenium commands, pull them out of our test, put them here. And now we have a dynamic method where we can specify any username and password combination we want. And then to check if the success message is present or even the failure message, we have separate methods that will return Booleans for us. And in the constructor, I'm handling how to get to the page and then checking to make sure that we're in the right place. Normally, you really don't want to have any assertions in your page objects, but this is one potential use case to break that rule. You could also instead raise an exception. There's several different ways to handle it. And during the break between sessions, if you have strong opinions about this, we can rap about it. But what this does is it gives us the ability to pull things out of our test, our Selenium commands and our locators, and then instead have something really simple. We create an instance of this login page object, pass in Selenium, and now we can log in with the username and password, and then assert that the success message was present. Our tests immediately become readable and immediately become maintainable, and then it's easy to add another test. So there's some additional page object helpers. What I showed you is just a very simple, plain old Java class. But there's things like HTML elements, which is from a company, Yandex. They're based out of Russia. They've done some tremendous open source libraries. HTML elements is one of them. It's a helpful wrapper around page objects that makes it a lot easier. There's also one built into Selenium called the Page Factory. These are both worth checking out. Or you can just stick with just writing your own classes. And there's one more that a lot of companies actually either have some variation of or just don't do it. I call it a base page object. It's essentially an additional facade layer. Some companies call it a Selenium wrapper. Some might just call it a base util class. But whatever you call it, what it is this. Right now, if we keep going the same path of how we're writing page objects, we would be writing Selenium commands directly in all of our page objects. And then if there was an update to Selenium that had breaking API changes, we'd have to go and update all of our page objects. Plus, we don't have really a central place to handle how we want to do exception handling unless we wanted to go through all of our page objects and put it in different places. So we don't really have a centralized place to control all that. So what we can do is create another abstraction layer. So we can move all of our base commands into this base page, and then those would reference the Selenium commands directly. So what this gets us is global reuse, and it insulates us from Selenium API changes, and this additional readability, more so than what we had before in our tests. And if you're interested in seeing why this matters and how it was done at scale, this link takes you to a write-up recap of the closing keynote from Selenium conference in Boston a couple of years ago, where Jason Labia from Google talked about migrating millions of tests from Selenium 1 to Selenium 2 and how this pattern is what they used to effectively do that. Now granted, going from Selenium 2 to Selenium 3 should, fingers crossed, not be a rocky ride like it was from 1 to 2, but this is just another helpful abstraction that could save you some time down the road. So what that looks like, a very simple base page object, is this. I'm basically creating and taking the methods and creating my own. I'm creating a domain-specific language where I have, instead of get, I have visit. And then instead of find element, I have find, and then I have click. And instead of send keys, I have type. There's submit, and then I handle the try catch for the exceptions here. So now it's just done in one place. So now we're not repeating ourselves. We have central location, and we're starting to be in a position where we can extend functionality if we need to. It's a little more robust. So what that looks like in the page object for login is this. Now we just have, instead of driver.get, it's just visit the URL. And then all the other methods that we just created. So now our page objects become more readable. So it all fits together as tests use the page objects. Page objects inherits from the base page object, and then the base page object ends up using Selenium actions. So now that we have all that, let's talk about making tests resilient. Probably the meat of this, really, what it takes to do Selenium really successfully, aside from all the table stakes stuff that I've already covered. It has to do with weighting, making sure that your tests are resilient with the way your web application behaves. Because how many people here use JavaScript? Only 4. Okay, great. Well, then this will be easy for you. No, in the sense of how many people test applications that have JavaScript? That's a better question. All of you, great, okay. So there's 3 ways to wait in your tests. And I'll let you wager a guess which one you shouldn't do first. Thread sleep. Don't use a thread sleep. And if you're curious why, the easy answer is it's a bad idea. By adding thread sleeps, you actually force your tests into always waiting that amount of time. There's no dynamic flexibility to how long your tests take to run. Within Selenium, there's 2 wait functions. There's an implicit wait, and then there's explicit waits. So an implicit wait, when you create an instance of Selenium, you can just say, wait for this amount of time. So every action that Selenium does, if it tries something and it's not able to complete it, it will wait that default amount of time that you just specified. But there's a caveat. It doesn't cover all conditions for all actions. And depending on how your application is built, there are plenty of use cases where things fall through the cracks and your tests end up being brittle. Instead, you can use an explicit wait, which is a little bit different. And I'll explain that in the next slide, but what's important to note is that you should never mix an implicit wait with explicit waits. And that's because it will cause transient failures in your tests because there are differing implementations of implicit wait across all different browser drivers and in Selenium Remote. So really, you just shouldn't use an implicit wait. And instead, we'll use explicit waits, and I'll explain what those are. And if you're curious about more detail about the specifics, I have this write-up where actually I step through with code examples what I mean, and show some ways that you could abuse implicit and explicit waits if you really wanted to. But an explicit wait, let's talk about that. So with explicit waits, for an action that you want to add a wait to, so say you click a button and you want to wait a certain amount of time for something to happen, you would wrap it in an explicit wait. And so you specify an amount of time in the action you want to do, and Selenium will try that action repeatedly until either the action can be completed, and if it is, say it was, you said 10 seconds to wait, and it was able to complete it in 2 seconds, it'll move on. It'll just go to the next action after that. If it's not able to do it, it's going to keep trying for that amount of time you specified, and then once it hits that top level time, it's going to throw a timeout exception. And so what that looks like here is on the internet, there's this simple dynamic loading example where when you click start, loading bar appears, and then after a few seconds, it disappears and some text appears on the screen. So you can grab this locator, we can verify that this finished text is what we think, and so now we can write a test. But if we actually just wrote a test saying, open this page, click this button, and then see if something's displayed, it would fail because Selenium doesn't know to wait. It's dumb. It just won't wait. So what that would look like for the wait function, there's a couple different ways to do it, but the easiest one is to use the one that's built into Selenium. There's the WebDriver wait function. And I've created this private function that's just called wait for. It accepts an expected condition. And the expected condition that I'm passing in this example when I use this method is the visibility of the element located. So basically, what we're effectively doing is displayed. And we can also specify timeout. Now, the best way to do that I found to do this was have a conditional that checks to see if null is passed. If it is, use a default timeout you specify here. So for this example, the default timeout is 5 seconds. And then it'll wait until all of that happens. And so up here, what we can do is say, wait for expected condition of the visibility of the element. And in here, I'm making it so it's optional to pass an explicit wait time. So when we call wait for is displayed in our page object, we can just specify the locator. If we specify no timeout, 5 seconds will be how long it waits, or we can override it. So we're effectively getting the implicit wait functionality for free with this implementation, but we're also not going to run into issues later on. So what that looks like when we implement it inside of a page object that would exercise the page I showed you, it's this. You visit the page, and you click start, and then you wait for is displayed, and you pass in the locator, and then we override the default timeout, say 10 seconds. So when you run this test, once we wire this up to a test, it'll run, and it'll actually wait. So there's some additional browser timing considerations to think about. Since synchronization is the biggest challenge, I think, in doing successful test automation, aside from all the normal infrastructure challenges. Most people, what they'll do is they'll write their tests in the browser that they're comfortable with. And usually, within Selenium, the easiest browser to get access to is Firefox, because it comes built into Selenium. And most people already use Firefox, so they're good to go. So you write your tests. You say, hey, I got working tests. Awesome. Now I'm going to run them in another browser. So you set up another browser, and you run your tests, and then you start getting failures. And you're like, wait, they were working in this other browser. What happened? And there's a lot of reasons for it. It could be that your application you're testing is actually responding more slowly because of load, but it's probably actually that the browser is executing in a different pace than what you wrote your tests against. So say, for example, you write your tests in Firefox, and then you go and test in Internet Explorer 8. It's not necessarily an advised idea, but say an older browser that's slower, like IE. And what you'll end up with is maybe IE runs a little slower, and your tests need to be tweaked so the timing can actually wait a little bit longer. And then you do that, so then you have working tests in IE and Firefox, and you say, let's go to Chrome. And then all of a sudden you have your tests breaking in Chrome for different reasons, probably because Chrome moves a little too fast, and then you missed some wait conditions you need to add to other parts of your test. And then basically what you end up with is these explicit waits kind of sprinkled around your test code. A lot of people think that's a smell, but really that's the recommended approach by Selenium committers as opposed to using an implicit wait. But it's worth it because what you end up with then is tests that work in all these browsers. But you can't really just write your tests once and have them run in all browsers. It's not as easy as that. It's an iterative process where you have to tweak it constantly and keep trying until it gets to a point where all your tests are green in all your browsers. Okay, prep for use. And how am I on time? Ish? Okay, great. Step 7, prep for use. So since everybody here already has a test harness that they built themselves or they're thinking about it, let's just go ahead and talk about building a test harness with Selenium. So the first thing is a simple organizational structure. The first thing any company ever deals with when a new software project happens, aside from what tool are we going to use, since we already know it's Selenium, it's like, where do things live? What's the folder structure? And then you want to make sure that you pull things out of your test, so each test isn't responsible for setting up and tearing down Selenium. You want to put it in a central place, so that way you can add more stuff to it. So you can say, oh, not just Firefox, I want Chrome, and then I want to run it on a grid, and so on and so forth. And then you want to make sure that your tests, you just write your tests, and then at runtime you can configure which browser you want to be used. And then also other things like a base URL and other kinds of sensible defaults. And then the other important thing is when a test fails, you want to know what happened. You want as much information as possible. You know, with Selenium that has the ability to take screenshots out of the browser. Your test framework that you're running on, your unit testing framework, should give you a lot of logging information, but then you can also attach a logger and output a whole bunch of additional debugging info. So really, a lot of times what could happen is you run your tests, if there's failures, you rerun your tests, and then they pass. And that's not helpful. You can't really trace down issues that way. So the best thing you could do is find as much debugging info as possible to look at your tests when they failed to figure out what actually was going on. And then you want to be sure that you run things in parallel. Because it's great that you have all these robust tests now, but what about not running them in series? Running them, as many of them at once as possible. And then you want a way to flexibly and easily run your tests into dynamic groups at runtime. So folder structure. It's boring. Let's go on to this. Central setup and teardown would look something like this, where you have some sort of ability to actually set up something before and something after. And in our test before, we were using before and after annotations, but pulling them out into a central base class like this, using before and after annotations would actually remove them from being useful in your tests because the order would be wrong. So in this example, I'm creating a base test, and then I'm going to update my test to inherit that, extend that. And so in JUnit, there's actually an external resource test rule that gives you the ability to fire a before method before the before annotation. So if that's not clever enough, this is the only clever thing I'm doing. Just whatever I said about clever, you can ignore it for this right here. So, but this gives you the ability to have a centralized place to store your setup and teardown code and then extend it. And if you're curious about JUnit rules, there's that URL, goes to the documentation. And then some way to specify config variables. So I mentioned runtime configurable. The way that I've approached it in JUnit is to use -d flags, so runtime properties, and then have a way to catch those and put them into values that I can pass around in a config object, and then have sensible defaults. So if I specify nothing, my tests will still run, right? They'll run in the most important browser, I think, at the time, which according to this is Firefox 33 on Windows XP. Okay. And then you would just implement the config interface in wherever you want. It could be in your base test, it could be in a base page object, but then you have access to the browser and all the other goodies like a base URL and so on and so forth. And in terms of reporting and logging, what I mean by that is machine-readable things like JUnit XML that can be consumed by your continuous integration server, and then human-readable things like screenshots, failure messages, stack trace information, so you could find that smoking gun. And there's actually, I mentioned the Yandex guys earlier, and they have this fantastic reporting tool called Allure that it's actually language agnostic. They have bindings for pretty much every test framework that's out there for every language. And anything that's not already there, they'll add it if you, they'll probably add it if you send them a support request. So at this link, I have a write-up of how to do it using Ruby and RSpec, but the documentation is really good too. So it's worth checking out because they make it very easy to get a very robust HTML report generator with screenshots. And so if you don't already have that, you don't necessarily need to build it. Someone else already has. And then parallelization. There's a few ways to handle it. There's always writing your own code. Your test runner may already support it. And then there's also certain continuous integration servers that handle it too, like Solano Labs, like TDDEM is one option. But the way for Java and JUnit, something like the Maven Surefire plugin or the Maven Failsafe plugin, fantastic. It's literally like a block of XML in your POM XML file, and you have parallel execution. It's amazing. And the pro tip here that I have is when running tests in parallel, there will be transient failures. That is just the name of the game, especially if you have test dependencies and you don't know it. And the best way to bubble those up is to run your tests in random order all the time. And within JUnit, there is another library that handles that for you. It just gives you the ability to add another run with parameter, like a little annotation, then your tests are then running in random order. It's fantastic. It also gives you the added benefit of exercising your application in random order, which could also identify and bubble up bugs in the app. And I'm getting close to the end, so I think, okay. Oh, we want to stop here? Cool. All right, you want to take a break? Cool. All right, we'll take a break.